Okay, I'm going to walk through a free response problem. This is one we've done already, but I just want to get your head back in the game in terms of how to attack the free response problem. There's one 25 minutes this year, there's one 15 minutes this year. Normally there are 15 minutes, okay? So I look at this problem, okay, there's a table, it's got F data, F and F prime, G and G prime. If I read it, the functions F and G have continuous second derivatives. Again, that means they're really well-behaved functions. There's no monkey business, okay? The table above gives values of the functions and their derivatives at selected values of x. It's always important to know what they're giving you. They're giving you the function and its first derivative. Okay, so now let's get down to the problem. There's three parts. They're not necessarily related. You might not know how to do the first part, but you can do the second or the third. So let's see. So let k of x, so they're defining a new function, equal f of g of x. So this is a composite function. The g function's inside of the f function. Write an equation for the line tangent to the graph. So they want the equation of a line tangent. Tangent means first derivative. That makes me think I need the point slope form of the tangent line. That's how I'm going to attack that. You want to think before you work. So I need the point slope form of the tangent line. And I'm going to get it when x equals 3. Okay? So I need the point slope form of a tangent line when x equals 3. So to do that, I need, so I'm going to do A here. I know I usually have you guys think about all three at once, so I'm going to start this one. So I need K prime. I need the first derivative. Okay? It's a composite function. So it's going to be f prime of g of x times g prime of x. Guys, that's the chain rule. Okay? Now they want k prime of 3. So that's going to be f prime of g of 3 times g prime of 3. Okay, and this is something tricked a bunch of you throughout the year. What I then get is k prime of 3. It's f prime. What's g of 3? Well, if I look up here, when x is 3, g of 3 is 6. So I end up getting f prime of 6 because g of 3 is 6 times g prime of 3. Okay? F prime of 6, when x is 6, f prime of 6 is 5. G prime of 3, when x is 3, g prime is 2. So I get 5 times 2, I get 10. So my slope is m. Okay? So I need point slope. So m, the slope, equals 10. And now the point. I know x equals 3. When x equals 3, what does k of 3 equal? Well, k of 3 is f of g of 3. Okay? G of 3 is 6. So I get f of 6. When x is 6, f is 4. So guys, this is my equation. Y minus, so the point, guys, the point is 3 comma 4. That's x1, y1. Okay? x1, y1 is 3 comma 4. So y minus 3 equals the slope times, sorry, it's y minus 4. Y minus 4 equals x minus 3. That's good for the first part. And you can leave it in point slope form. In fact, I suggest you leave it in point slope form. Okay? Okay, part B. Now they're defining another function, h of x this time, and it is a quotient. Okay? It's a quotient. It's a function over a function. They want h prime of 1. So guys, I need the quotient rule when x equals 1. Okay? So that's what I'm doing. I need the quotient rule for the second problem. Okay? So B. H prime, let's see, it's going to be high, sorry. Okay, guys, sorry. So h of x is g of x over f of x. So h prime of x, it's going to be low times the derivative of the high minus the high times the derivative of the low, all over the low squared, okay? So guys, that's the derivative. So h prime of 1, so I get it's f of 1 times g prime of 1 minus g of 1 times f prime of 1 all over f of 1 squared. I kind of recommend that you do it this way. You write it out before you go to plug in numbers in. You're less likely to make a mistake. So f of 1 is negative 6. G prime of 1 is 8 minus g of 1 is 2, and f prime of 1 is 3, all over f of 1 is negative 6 squared. So if you do that, you get negative 48 minus 6 over 36, which is negative 54 over 36, which is negative 3/2. Guys, I would leave it like that. I wouldn't reduce the fraction, because if you reduce it wrong, you're going to lose points. So that's B. Okay, C. Evaluate the integral. Evaluate the second derivative. Okay, so a little bit of a twist here. I'm not integrating f double prime of x. I'm integrating f double prime of 2x. So there's a little bit of u sub in there. So guys, I'm going to have to go to a separate sheet of paper because I'm kind of out of room here. So I'm going to do that here. So C, all right, what they're looking for me to do is integral from 1 to 3 f double prime 2x dx, okay? All right, so I'm going to do a little bit of a u sub here. I'm going to say u equals 2x, so du equals 2 dx, okay? So this integral is going to become 1/2, guys, sorry, let me change the limits to when x equals 1, u equals 2, when x equals 3, u equals 6. Because remember, u equals 2x. So guys, my integral, so dx is going to be replaced by 1/2 du. So I'm going to get 1/2 the integral from 2 to 6 f double prime of u du. Okay? So if you remember the fundamental theorem of calculus, this is 1/2 the integral of f double prime is f prime of u from 2 to 6. So guys, it equals 1/2 f prime of 6 minus f prime of 2. Okay? That equals 1/2 f prime of 6. F prime of 6 is 5 minus f prime of 2 is negative 2. So it's 1/2 times 7, 7/2. That's it. Guys, here goes the scoring guideline you can see online. Okay? 3 points for part A, 3 points for doing the chain rule and then getting the equation of the line. So two points to do the chain rule, 1 point to actually find m and write the equation of the line. See how they wrote it? Pretty similar to what I did. The next one was a quotient rule. 3 points for the quotient rule. So 2 points to actually take the quotient rule, and then 1 point to plug it in. And then the last one is another 3 points. So 2 for the antiderivative, and then 1 to actually plug the numbers in. So not a bad problem.